All right, this is Professor Pelton. This is part 2 of chapter 5, section 2. So there's a little practice and substitution first. What you have to remember is when you do this function stuff that the odds and evens really are important in following order of operations. So whenever you do substitution, you should always make parentheses. So anywhere there's an x, you need to put, or whatever the variable you're substituting in parentheses, because that maintains the order of operations. Without the parentheses, you're not maintaining the order of operations. You get a different outcome. So the function value at -4 is equal to exponents first. So 4 times 4 is 16 times 4 more is 64, plus 3 times positive 16 plus 9. So I have odds versus evens. So the odd exponent gives me a negative. The even exponent gives me a positive as a result. So f of -4 equals 64 when I multiply. And then let's see here. So that's 30 and 18 is what? 48 plus 9. So f of -4 equals, let's see, so 64 and 48. So that's what? 108 plus 9 is what? 121. Here we go. All right, so pause the video. Try the student problem for yourself. Okay, so if I'm going to plug in -2, oh boy, I need to maintain the order of operations, so the parentheses are very important. That goes for all levels of math whenever you substitute. If you do not use grouping symbols, then the order of operations is lost. So I'm going to plug in my value of -2. So the function value at -2, so exponents come before multiply and add. So I'm getting 2 to the 5th power, so that's what? 2, 4, 8, 16, 32, but that's negative because there's odd number. And then that'll be 16 here because it's positive because it's an even number. Okay, so the function value at -2. Okay, so now we can multiply. So we get what? 96, -96, minus 16, plus 12, and then plus 10, right? There we go. So the function value at -2 is as follows. Okay, so we have 96 and 16, right? So 96 and 16, that'd be what? 112. Take away 22, so that'd be what? 90, but -90, right? Okay. So essentially what you really have over here is a coordinate of -4, comma, 121. And down here, what you really have is a coordinate of -2, comma, -90, right? Okay, but just using it in function notation. All right, so we established what a polynomial is, and then how to plug in values into a polynomial. So now we want to talk about what they look like graphically. So graphs of polynomials are continuous. So that thus, when you draw, you're not going to pick up your pen or pencil and then put it back down. There's no jumps, no holes, no asymptotes, so on and so forth. It's smooth, which means there's going to be no cusps, corners, anything like that. No, it's going to be nice and smooth, right? Okay, so if I look at the following graphs, which one is a polynomial, which one is not a polynomial? So the second one has a jump, right? So not a polynomial. Has a jump, right? It's a discontinuity. Okay, so this is a polynomial because if I draw it, I can draw this and it's continuous, meaning I don't need to pick up my pen and it's nice and smooth. There's no corners or cusps or anything like that. Okay, all right, pause the video, try the student problem for yourself. Okay, so if I look at the student problem, okay, so this is not a polynomial, right? So not smooth. You can't have corners or cusps or anything like that. Not a polynomial. Okay, so this one is a polynomial. Okay, because if I put my pen on there, I can draw it. There's no corners, no cusps, and I don't have to pick up my pen at all because it's continuous. because that follows the definition basically. Okay. All right, let's go to the next page, which seems to be going the wrong direction. Let's try this again. All right, so now we want to talk about the end behavior, which really comes down to two factors, the leading exponent and the leading coefficient. So we wrote the polynomials before. The only thing that mattered is the leading term once it's in proper order. The rest of them don't matter. Think of it this way. The first one to finish the race is the one that matters, right? So the leading exponent and the leading coefficient are what dictates the outcome. Because if the exponent is even, the outcome will always be the same. If the exponent is odd, the outcomes are different. The leading coefficient just switches the outcomes. Positive is what you think, and negative is going to negate it essentially, right? And end behavior is essentially what's happening to the graph as you go out towards infinity. That's what we mean by end behavior. What happens to the end with the graph, essentially. Okay. Oh, let me fix this end there. Okay, so there are only four possible end behaviors for a polynomial. So they either go, because you read a book left to right, right? You read a book left to right, correct? So it goes down, up, down, up, or down, down. That is the only possible end behaviors there are, right? Notice there's dotted lines in between here, not dotted lines, because what happens in between is irrelevant. We only care about the end behavior. So think of it this way. We'll start with the even exponent, right? Take x to any power that's even. So I don't know, fourth power works, or sixth power, or second power. Any number you plug into there is going to be positive. Put a positive number in there, you get a positive. Put a negative number in there, you get a positive, right? So if I do 2 to the fourth power, I get a positive. If I do negative 2 to the fourth power, I get a positive. So the outcome, right, is up as the end behavior. However, if I put a negative number out front, like a -6, the exponent happens first, the multiply happens second. So the outcome is always negative, negative, right? So in this case, you're going to go down forever, right? No matter what happens, because the exponent's going to always make this positive, right? And the negative makes it always negative as far as that. So order of operations makes a difference, right? So if I change this to +6, it becomes this one, doesn't it? Right? And it doesn't matter whether it's a 6 or an 8 or a 12 or whatever this coefficient does, it doesn't matter, right? Okay. So essentially what we have here, if you think about it, is this is an even exponent, right? And a positive coefficient, right? Which is what the A is here. This is a negative coefficient, correct? Which is what we have here. All right, let's go over to here. So let's choose something that's odd, right? Odd exponent. So how about x to the third power, right? If I plug a negative into there, it's negative. If I plug a positive into there, it's positive. So in the positive direction, I'm going positive. In the negative direction, I'm going negative. That makes absolute sense. So if I put a number out here like a 7, that doesn't change anything, right? But if I put a -7, that flips it, correct? Because the first part is negative and the second part is negative, so you get a positive. So in the negative direction, you go positive, right? And then if I plug a positive number into there, it's multiplied by a negative. So in the positive direction, I go negative, right? So this is a positive coefficient. This is a negative coefficient. So what you have to remember in both cases, it's a times x to the n power, right? If the exponent comes first, the multiply comes after. Follow the order of operations, it dictates the outcome, right? Is the exponent even or odd? Is the coefficient positive or negative? You don't need to memorize these, just think about basic math. If you plug a number in, what's going to happen? Because you can only plug in a positive direction number or a negative direction number. What happens? Okay. All right, so let's scroll down a little bit, fill in the table. Okay, so this is the basic table here. So it dictates the directions based on odd and even, and the coefficients are over here, right? So these are the coefficients, and these are the exponents, correct? For the a sub n to the x to the n power, right? So the only question is what happens in between, okay? So it's the n minus 1 rule. So if I'm to the 8th power, I have at most 7 changes in direction, right? If my exponent is 3, then I have at most 2 changes in direction. So whatever the highest exponent is, that leading term, that's going to dictate the most changes in direction. There's a way to figure out the changes in direction. We're going to just do the most in the meantime for these to make it easy. Okay, so let's look at these as an example. Okay, so what is the degree here? Well, it's a 1, so that is odd. The coefficient is positive. The coefficient is negative, right? Because this is a positive 1, an odd 1. This is an odd and a negative, right? Okay, so as x goes in the positive direction, right? That's what we're looking at here. What happens to the function? The function is approaching positive infinity. As x goes in the negative direction, what happens to the function? The function goes to negative infinity, correct? So that is the outcome of an odd degree positive function. If I do an odd degree negative function, what happens? As x goes in the net positive direction, so as x goes in the positive direction, the function goes negative. As x goes in the negative direction, the function goes in the positive direction. Okay, let's try the next ones. So now we get x squared. So this is even and even, right? Because you're looking at a 2 in both cases, right? A 2, right? And the coefficient is positive because it's a 1, or it's a negative 1 here, correct? So you notice whether I go in the positive or in the negative direction, x goes in the positive direction, x goes in the negative direction, the function always goes up. So in an even function with a positive coefficient, I always go up, which makes sense. And no matter what direction I go with x here, the function, I'm sorry, I almost put positive there again, goes down. So a even powered function with a negative coefficient always goes down as far as the function values for the end behavior, right? All right. Take a second and try the student problems for yourself. Okay, so in this one, we have an odd degree, right? Because the odd is the 3. And then this one, we have an even, which is the 4, correct? So the coefficient is positive. The coefficient is negative because you have a negative 1 and a positive 1. So the minus 2 makes no difference because you only look at the leading term here, right? The coefficient is positive. The coefficient is negative because you're looking at the positive 1, the negative 1. So the other terms don't matter. You only look at the leading term. All right, so as x goes in the positive direction, the function goes to positive infinity. As x goes in the negative direction, the function goes to negative infinity. So in the next case, as x goes to positive infinity, the function goes down. And as x goes to negative infinity, the function goes up. Right? And the next one, regardless of the direction of x, the function always goes up for even exponents with positive coefficients. And in both cases here, the function goes down to negative infinity for even functions with a negative coefficient. So we look at these answers here and compare them to the ones above in the example that I did. They're exactly the same answer. right? Because you'll notice that these answers match if you go up the page, because all odds and evens have the same outcome. So if I did another page and I did the fifth power and the sixth power, I would get the same exact answers again, because there's only 4 possible outcomes for end behavior, and they always look the same. The only thing that differs is the number of curves that are in between, essentially. That is the end of part 2.